Here are solutions to homework set number 3 for ECE 111, Introduction to ECE. This homework set looks at using Matlab to solve problems that you'll encounter when you take Math 105 trigonometry. Now, trigonometry is all about the unit circle, sines and cosines. One type of problem you'll encounter is adding numbers in polar form. So if I take three vectors, A is 6 at minus 93 degrees, plus 11 at 70 degrees, plus 8 at 87 degrees, where do I wind up? Well, one way to do that is to find the x and y component of each vector. So x is the amplitude times cosine of the angle, y is the amplitude times sine of the angle. And in Matlab, the default is radians, natural units, so I have to convert degrees to radians, which is times pi over 180. So the first one, the x-coordinate is minus 0.3, y is minus 5.9, likewise for the second one, likewise for the third. The answer then is the x-coordinate is add up the x's, add up the y's, so that's where I wind up. Now I can do this on an HP calculator as well. I kind of push HP calculators. They are worth 10 points on a midterm, in my opinion. There's a couple of them out there. The one that's still in production is the HP Prime. To use it, what I need to do is go to RPN mode. So if I go to Settings, Entry, make sure that's RPN. RPN is reverse Polish notation. It's a little bit weird, but once you get used to it, it's really, really fast. Back to Settings to get back. So here's my calculator. To add numbers, there is no equals. To add, I use the stack. So to add like 2 and 3, I say 2, enter 3. Those numbers are on the stack. I can now add them. To do polar forms, I want to enter 6 at minus 93 degrees. So that's 6, angle, negative 93. So there's 6 at minus 93 degrees. Enter. Add it to 11 at 70 degrees. 11, angle, 70. Add those. Plus 8 at 87 degrees. 8, add an angle of 87. Add. Voila, here's my answer. So it's 12.9 at 72 degrees. If I hit angle again, that converts to rectangular form. 3.86 plus 12.37. And the numbers should match. I'm not quite sure why they don't. Minus 5 plus 10 plus 7 is 12. So I got something weird right here. But anyway, that is the right answer. Problem 2. Add these vectors together. So again, what you do is convert to rectangular form the x and y coordinate of the first point vector, x and y the second, x and y the third, add the x's, add the y's, here's your answer. Or in an HP calculator, I can do it a whole lot easier. All I need to do is just say, enter the first one, enter the second angle, add it, third angle, add it, and voila, same answer. Problem 3. Where is B relative to A? Well, to do that, I just take the difference in the x-coordinate, difference in the y-coordinate. So B relative to A is 27 in the x direction minus 4 in the y direction. And polar form is the amplitude, square root of x squared plus y squared, is 28 away, and the angle is the arctan 2 function, y over x. It is at minus 9.8 degrees. So this converts to 2 degrees. In Matlab, again, everything is radians. So to get to degrees, you got to convert. That's the first 3 problems. Problem number 4, plotting functions in Matlab. The plot function uses rectangular coordinates. When I plot, it's always x versus y. If I want to plot something in polar, I've got to calculate the x-coordinate and the y-coordinate. For example, if I have r is 2 sine theta plus 3 cosine theta, I'll have theta go from 0 to 2 pi. So this is one way to do that. It goes from 0 to 1, steps of 0.01, times 2 pi, so it goes 0 to 2 pi. Calculate r. Now I want to pull out the x and y coordinate. The x-coordinate is r cosine theta, y is r sine theta. I've got to use that dot notation. That tells Matlab, don't do a matrix multiply, do an element by element multiplying. The first point, second point, third point, and so on. Then plot them, and not too surprisingly, you get a circle. Trig functions are all about circles. If I take a different polar function, r is 2 pi minus theta times 2 pi plus theta, plot it. Here's theta, calculate r, pull out the x-coordinate, pull out the y-coordinate, you get kind of a heart. Kind of like Valentine's Day. If I do r is theta squared, from minus 2 pi to plus 2 pi, calculate r, pull out the x-coordinate, pull out the y-coordinate, I get another variation of a heart. And this kind of preparation for Valentine's Day, you can come up with a mathematical equation for a heart. Okay, problem 5 onward looks at another application of trigonometry. This is with robotics. If I have a robot arm that has 3 axes, so here's the xy, I start with the first length, has a length of 3 meters. Here's the first angle. The second angle is relative to the first angle. So this is theta 2 right here. Here's the second link, length of 2. Here's the third link, length of 1. If I specify the angles theta 1, theta 2, theta 3, where is the tip? That's called forward kinematics. Well, to do that, that's just a bunch of trig. The first point right here, x1, y1, that's just the radius times the cosine of the angle, radius times sine of the angle for x and y. The second joint is where the first joint was, plus the length of 2 times the cosine of its angle. In robotics, the total angle is actually the theta 1 plus theta 2. The third link has a length of 1. Its total angle is theta 1 plus theta 2 plus theta 3. So if I want to find out where's the robot at these joint angles, all I really have to do is, well, here's a function in Matlab. With Matlab, I can create functions. I pass it parameters, it returns parameters. So this is a function, that means a subroutine. I'm going to pass these angles, the name of it is RRR. Inside of it, I'll convert the angles to radians, so I can input them in degrees. It uses radians. Here's the base, the first link, the second link, the third link. Not required, but just for fun, let's plot it. And then return x3, y3. So here's how that works. Go into Matlab. I've got my function somewhere. There it is. This has to be saved as RRR. The name of the function should be the name of the file, rrr.m. If I try to run it, I get an error message. You cannot run functions, but I can call them. I can say what is if I have these angles, where is the robot? And it says the tip is at 3.3 meters minus 0.61 meters. And just for fun, I drew it. If I give it different angles, let's try 61 degrees minus 44 degrees. Now that's where the robot is. That's forward kinematics. So with that, if I plug in 41 degrees minus 94 degrees, 45 degrees, here's the orientation, there's the tip position. If I try a different set of angles, there's the orientation, here's the base, down, over, down, and the tip position. So forward kinematics is pretty straightforward. It's just number crunching. Problem 7 is inverse kinematics. What angles put you at 2, 0? So to do that, what I'm going to do is create a new function. One of the powers of Matlab is once you create a function, you can use it. I just created the function RRR. I pass it the angles, returns the tip position. I want to create a new function. I'm going to pass a vector that contains the joint angles. I'll calculate the position, then return the distance from the tip to 0.20. So if I try that, here is my function in Matlab. Again, I cannot call it or execute it. If I do that, I get an error message. You can't run subroutines, but I can call a subroutine. So if I say, what is problem 7 at angles of 30, 40, 50 degrees, it says there's the robot, here's the tip position, and the distance is 18.6. Oh. And optionally, that's the distance, square root. Try that again. Distance is 4.31 meters away. Can I get closer? So what I can do is guess again, guess again. Let's try to make this minus 40 degrees. Okay, let's make it minus 80 degrees. Make that minus 50 degrees. I'm trying to get the tip over to here. Distance gets smaller and smaller. So I can guess again, or I can let Matlab guess for me. That's the function fmin search. Let's do fmin search. I want to minimize this function, problem 7, and here's my initial guess. So it's going to sit there, guess again, and eventually, when it minimizes the error, it will return an answer. And in this case, the answer that I got is, drum roll please, right here, 52.2 degrees, minus 113 degrees, minus 80 degrees. Now this answer is not unique. If I give it a random initial guess, here's just a bunch of random numbers, it's my first guess, it'll wind up at a different solution. When I have 2 constraints, 3 degrees of freedom, there's almost always an infinite number of solutions. And sometimes it cannot find it. Here it goes. Now it's finding the solution. Got it. Different answer. So that's homework set number 3 for ECE 111. Again, the note about this homework set is Matlab is a really useful program. With it, I can do trig functions. Probably more importantly, I can do subroutines. I can create functions in Matlab. Once I do that, I can have a function call a function. That's one of the reasons Matlab took off. In industry, you can create your own custom functions so that each company can come up with better designs than their competitors because they have their own custom functions they made in Matlab. So functions are something you're going to use quite a bit over the next 4 years. And that's homework set number 3 for ECE 111.